On the biofuels piece, we're in that space too. We thought that biofuels would be actually something we could do at scale, and we try to do things at scale. So we are in the renewable business to do things at scale to make a difference for our company, and the industry needs to do that too. So what do we do in the area of biofuels? We partner up with a company called Weyerhaeuser, which is a forestry products company, and we've got 1 million acres of land. We're trying to figure out how do you convert that into biofuels. And to address Amory's point specifically, when we first went into that, we thought we could take that 1 million acres and convert that into about maybe 250,000 barrels a day equivalent of biofuels. As we've worked it, we've looked at the cultivation and the mass that comes off the land and the transportation losses you get by accumulating it. We're probably thinking around 50,000 barrels a day, if that works, if technology works. And we think we can get the technology to work. That's 50,000 barrels a day out of US 22 million barrel a day consumption on oil. That's 1 million acres with one of the largest landowners in the United States. So then we start looking a little bit of the math, and this is where I think maybe Amory and I have had a good discussion. Biofuels from biomass. Our company says, let's stay away from food. We don't want to have food versus fuel issues. So we don't like corn. We don't like anything that goes on people's dinner plates. We're figuring out how to use waste. And the competition for biomass, not only for biomass to biofuels liquids, but potentially biomass to help reduce impact in coal-fired plants, which is using some form of biomass to help reduce their emissions over time. The competition for biomass is going to potentially drive up the cost of biomass, and eventually we reach a limit, certainly in the United States, as to how much we can create there. I don't know exactly where that's going to go, but we're working in that space as well. I think finally, things that we are aligned on. I think bulk of what Amory said, we think, in fact, we're acting in the way that I think Amory is suggesting we all need to look at the future. The real difference is probably in the time frame and the scale with which we can do this. How fast can we do this? And we don't manufacture cars, but we do know that vehicles now have an increasingly longer lifespan, maybe 17, 18 years. The fleet maybe turns over 7-8% per year. So if we started, today with everything brand new, that would work. We think that would, we probably have good alignment. But people, because of the economy, are holding things on. They're holding on to their vehicles longer still, and they're actually better built. So to turn over the fleet takes a little bit of time. And even with the Prius, which we see that as being a high sales unit, 2-3% sales, is still a very small percentage of the overall vehicle fleet. So I think in principle we agree pretty much. It's just a matter of the time frame, and in the end, for some of the alternatives, do we have a really clear view of the unintended consequences of the integration and the intersection of agriculture and energy supply chains? The intersection of water, agriculture, and energy. Many of the renewable energies we're now working with, we know take a lot of water, and that becomes a critical factor. So it's not necessarily a disagreement with what Amory's saying, as much as it is support for the direction and differences in the pace and the scale and the time frame we can execute in.
Okay, so now, we're not going to have these guys argue. I want to go straight to questions, so right here.
Hi, I'm Brian Wong. I have the Next Big Future website. A question I have, a suggestion would be to convert cars faster, because the time to take and make new cars takes longer. Could there be a way to mass retrofit the existing fleet, certainly with trucks first and then with the regular cars, where you can make them more aerodynamic and thus use less fuel at highway speeds? And then a question about micropower. Isn't that just natural gas and diesel, because it's not wind and solar, which was separate on the chart? And the external E study of deaths per terawatt puts natural gas still at 4 deaths per terawatt versus 0.04 or in that range for nuclear and 0.15 and stuff for wind and solar. So micropower seems to be more dangerous than nuclear because it's natural gas and not really away from fossil fuels. So the two aspects of it.
Yeah, maybe on the micropower, on the car issue, maybe you could address the micropower. But on the car issue, last night we had a discussion. I don't know if he's still here. I think it was Jay from Rapid Car. is doing retrofits, and maybe he'd be best to answer that question offline. But certainly, it's going to take a combination of factors. New vehicle design, lighter weight materials, like Amory's talking about, retrofitting, and in this particular case, I think it's a good model because it's a fleet model, and it's also integrated with the grid and V2G and those kind of things, which actually have multiple benefits in addition to the vehicle efficiency. So that would be my response on the car issue. Certainly going forward, how many in the room have actually ordered their new Volt? We got one. That's one. And again, back to the question of, will people pay $41,000 for a vehicle that's, more efficient over time? I don't know the answer to that question, but GM has certainly tried to make that a very attractive vehicle. They've gotten rid of the range anxiety by putting a small gasoline engine in it, so it goes, it doesn't have to worry about recharging. And, there's still an adoption. We're techonomists, right? So we kind of feel comfortable with these vehicles. My daughter is not a techonomist. She called me at 1 o'clock in the morning on a turnpike between Boston and New York, and she was driving her Prius, and she's a vegan, for those of you who were here yesterday, as well. And she called me at 1 o'clock in the morning. She said, "Dad, I'm broken down the side of the turnpike here, and it's dark, and I'm kind of frightened." And I said, "Well, what's wrong?" I said, "Do you have gas in the car?" And she said, "No, but I thought when the thing ran out of gas, the thing would keep going because it's electricity." So from that standpoint, there are early adopters who can appreciate it and those who don't quite get it just yet. Amory?
It's well known in the car business, people will run out of gas no matter how big the tank is. I didn't understand your micropower question, but I thought you were referring to carbon emissions, and we should talk offline about the numbers, which I don't think are correct according to the peer-reviewed literature. But I will just say you need to look not only at carbon emissions per kilowatt hour, but also at opportunity cost. That was the point of my last remark about how the combination of efficiency, renewables, cogeneration saves 20 to 40 times more carbon per dollar and 2 to 20 times more carbon per dollar and 20 to 40 times more carbon per year than new nuclear build. And you need to look at those opportunity costs because you can't spend the same dollar on two different things at the same time. And the nuclear industry is desperately keen that you not think about that issue.
No, I was thinking that the micropower is still fossil fuel.
The cogeneration part is mainly fossil fueled, very largely natural gas. However, that's releasing less than half the carbon that it would otherwise, burning the same natural gas to make electricity and heat separately. So it's still a considerable carbon saving. And of course, a large and increasing fraction of micropower is renewable.
Okay, we have a question right here.
So I'm Jim Smith with Digital Realty Trust, and we develop data centers, lots of very large data centers. And so, Amory, I need help.
I'll be happy to show you offline how to get 100-fold energy leverage on your data centers.
Your leverage point at the source is really important, and I'm the point of that spear, right? The IT load in my sites gets levered all the way up to the efficiency chain. And I have some wonderful, wonderful designs in Santa Clara that use outside air. They approach 90% efficiency. They're great, great products. They save my customers tons of money. The further I get from Santa Clara, the lower the adoption rate goes. Even in Santa Clara, if I were to put one in front of the Chevron IT team, there's no way they could go with a product like this because it's too different.
Well, we just did one in the north of England with EDS,
in England's
now
the
HP.
best. London is my favorite place to propose these. Yet the customer base there, because they're so conservative and very traditional around the IT
I'm going to reinforce your point. Namely, they ended up saving 3/4 of the energy and having 4 times the capability they wanted at the same CapEx. However, had the client allowed them to carry out all our recommendations, they figure they would have saved 95% of the energy and half the CapEx and not put in all those chillers that'll never run.
So this is the challenge I have as a techonomist and an actual industrialist building these things is I have all these ideas that I want to put out there, but the customers are resistant.
Competition's a really good way to get their attention.
But even when I have the economic case that's overwhelming, you hit these institutional barriers related to perceived risk or just the difference, right? They want it to look a certain way, and this one looks different, so there's this resistance. How do we get through that? Is that
I just work with the early adopters to create teachable cases and competitive pressure for emulation, and the other guys figure it out.
Can I maybe just add one point to Amory's response? In a large institution like Chevron, we have a VC firm, our own VC firm that actually brings in new ideas, potentially transformative ideas, including IT ideas. So, you know, we'd be welcome to talk about that.
Yep.
But part of the challenge, to be frank, on institutions is really knowing what your energy costs and efficiencies are in the IT space in a global company. You know, when we first set up the accounting system, we really never thought, I guess, many years ago, to figure out how many BTUs does an IT system use, taking into account the building and the coolers and the power to run it. And that's part of the challenge in being able to make the business case, is having the companies be able to find a way to account for that and know what their energy costs really are.
Fortunately for the macroeconomy, it appears that IT is a major energy net saver.
It is. That is
So,
I think there's a question straight back here. It's hard to see in the light, but
Okay.
yeah, go ahead. Okay.
Thank you, Peter. My name is Bryce Simmons, and I'm from Ghana. My question is actually for a bit of a clarification from Dr. Lovins about the reduction in fuel use due to the use of new materials. And I was wondering, particularly in connection with safety, and I was wondering whether my understanding was right, that a good deal of the weight is also contributed by non-metal parts, which also contribute to shielding and padding, like leather, upholstery, and the rest of it. And how, in that context, you know, the use of carbon fiber, for instance, will be sufficient for a significant reduction of the weight.
well, the energy absorption per kilogram is about 12 times as good for the sort of material I passed around as it is for steel. But even today, in today's fleet, which is largely homogeneous and almost all steel, at any given weight, there's a factor of 3 scatter in safety because of differences in design. And when the data that most people had concluded related weight to safety were reanalyzed, separating the previously conflated effects of size and weight, it turned out that weight kills people, size saves people because it gives you more protective crush space. Therefore, you want to decouple size from weight using metal or composite materials and design solutions. The result is you get cars that are big, if you like, which is protective and comfortable, without also making them heavy, which is hostile and inefficient. Therefore, you end up saving lives and oil and money all at the same time.
So Americans can keep their big cars.
Sure, but make them very light. Remember the car that's the interior volume of a Prius and 1/3 the weight, the one I showed from Toyota, that's an indication of where this is headed. By the way, if it were not a plug-in hybrid but a regular hybrid, that's 400 kilos curb weight, which coincidentally is what I said in 1991 a good 4-seat carbon car should weigh, to much hilarity from the industry, as you can imagine, so it's a thrill to see it happening.
And you don't have to be Arnold Schwarzenegger to lift the car anymore.
Nope.
Right, to tip over the taxi.
Haul it out of the ditch yourself.
Okay, I'm afraid we're out of time, and there are so many topics that I know needed to come up that haven't come up, but I hope that you'll continue the conversation now offline. And thank you both for
Thanks, Peter.
a wonderful presentation.
Thanks, John.
Thank you.